In this lesson, our first goal is just to kind of figure out a new way to do division. We all know long division. It's really it's called long division mainly because to me it's long. So we kind of find a different way, and this is called synthetic division. And this is first example. What it wants us to do is to find the quotient, which is what's left over after you divide one polynomial into the other. It's that thing that's usually written on the top of the box. The remainder, and then when you divide this first polynomial by x minus 1. Okay. So what we learned is this whole kind of thing called a box method. We're going to put a number over here in this box, and what's going to go to the right of that are the coefficients of our polynomial. So the coefficient of the highest powered, we're going to check to make sure it's in descending order. The coefficient of x to the fourth is 1, of x cubed is negative 2, so make sure I take that sign with it. There's no x squared, so let's put a 0 for that. Of x is 1. And then last thing is 7. Now the number that goes in the box is what you're dividing by. And see up here it says x minus 1. You always take the opposite of what looks like there. That's the kind of the easiest shortcut. As often as I've taught this, most of the students are just like, just give me the shortcut, so just take opposite. Of minus 1 is actually a positive 1. So how we're going to do this, we're going to draw a line, and we're going to leave some open area in here. We always take the first number and drop it down. So it's 1. Take that number, multiply it to the box. So 1 times 1 is 1, and put it right here in the middle. Then we're going to add this up. So negative 2 plus 1 is negative 1. Multiply that number to the box, which is negative 1, and add those up. Negative 1. Multiply that to the box, which is negative 1. Add it up, which is 0. Multiply 0 to the box is 0, and add it up is 7. And we are actually done kind of doing the division. So now it's about interpreting it. And the key thing to know is that when you go through this whole synthetic division is that what comes out here on the bottom part is always going to be a brand new polynomial. This last number is the remainder. So we'll call that the remainder. But what these first, looks like in this case is the first 4 numbers are going to be our coefficients of our new polynomial. And anytime you go through this, it's always going to knock you down your degree by 1. So starting out, our degree was 4 because it was x to the fourth. So now this first number right here is actually the coefficient on an x cubed. So it's 1x cubed minus 1x squared minus x. If you want to, we can go and say our constant is plus 0. This is not always going to be 0 every single time. So that right there is the quotient. It's what's left over, so we can call that q of x, and then our remainder is 7. We could write that remainder as either as 7, or we can write it as 7 over what we were dividing by, x minus 1. Okay, so let's take this whole same thoughts. Let's try this one more time so y'all can kind of get used to it. Again, in this next example, we're going to be dividing a polynomial by x minus 2. So let's set up this box, and what goes in the box is what you're dividing by, and we're always going to switch that sign. So if that was a positive 2, we'd put negative in here. But since it's a negative 2, we're going to go with positive. And the coefficient starting, make sure it's in descending order, and putting in zeros for blanks. So 2 for my x to the fifth, negative 1 for x to the fourth, negative 3 for x cubed. There's no x squareds, there's no x terms, and then finally 2. All right. So let's drop down that first number, 2, multiply it to the box, so 4, add it up, so 4 minus 1, or negative 1 plus 4 is 3, multiply it to the box is 6, add it up, 3, multiply it to the box, 6, add it up, 6, multiply it to the box, 12, add it up, multiply that to the box, and add it up. Okay, so this last number right here, we can separate that out. That's the remainder. And these first group of numbers, that's going to be our quotient. So our quotient, and to figure out the degree, it's always going to be 1 less. So we went through this process 1 time. So it's going to knock it from a 5th power to a 4th power. So it'll be 2x to the 4th plus 3x cubed plus 3x squared plus 6x, I'm going to kind of write this below it, plus 12. And our remainder is 26, or 26 over x minus 2. And there you go for that example. All right, in this next one, it's pretty much we're doing the exact same thing again. It's specifying exactly how they want us to write the form. Okay, so let's start out here in our box. We're dividing by x minus 2, so opposite of negative 2 is a positive 2. And this is what we're dividing into, so let's go with those coefficients. 1 for the x to the fourth, there's no x cubes, there's 1x squared, there's 3x, and there's a negative 9. Let's draw our line, drop the first number as is, multiply it to the box, add it up. Multiply it to the box, add it up. Multiply and add, multiply and add. So 26 minus 9 is 17. Okay, so that last little bit's our remainder, and here is our quotient. So we go from x to the fourth, now down by a degree. So we're going to go x cubed, 1x cubed plus 2x squared plus 5x plus 13, and then they tell us we want to go ahead and add on to our quotient the remainder over what we were dividing by. And there's our answer. All of that right there is all they're needing for this problem. So y'all can see, look, we just did 3 examples by probably about the time it would take us to do 1 by long division. So this is really, really, really nice. Okay. This problem right here really isn't much different from what we've been doing. All they really want us to do is, instead of writing it in the forms of locating or specifying exactly what the quotient is and what the remainder is, all they want us to do is basically find that remainder. That's all we have to do with this problem. So let's go with the box. The number that's going to go in the box is what we're dividing by, and take the opposite, negative 2. And we're going to go here for our coefficients. So x cubed will be 1, and x squared is a negative 1. A 5, and a negative 7. So there weren't any missing terms this time, which is okay. We don't need them all the time. Drop down 1, multiply it to the box, add it up. Multiply it to the box, so 6, add it up. Multiply it to the box, and add it up. Now remember, the remainder is always this last number right here, so that's all they want us to do, is just to list out, find out what the remainder is, and the remainder in this case is negative 29. That's all we had to find for this. Okay, now this next example is kind of why we're just focusing on the remainder, because if the remainder ever is 0, then we know that we have found, well, either 1 an x-intercept, or we found a way on how to help factor. Because if you look at this polynomial right here, and I asked you guys to factor it, other than maybe trying, the factor by 4 terms, and if that doesn't work, it's kind of hard to figure out how we're going to do this. Synthetic division is a way to figure this out, okay? So we're going to start with the box. What we're dividing, we're going to divide x plus 3 into this. So I'm going to put a negative 3 in here, and this we're going to make sure it's in descending order. It doesn't look like anything's missing. So we have a 3, an 8, a 3, and an 18. Okay. Drop the 3, multiply it to the box, add it up, negative 1, multiply it to the box, add it up, multiply it to the box, and add it up. This right here is very, very important, but because the remainder is 0, then we can say yes, x plus 3 is a factor. And what that means is that if I started out here with a function 3x cubed plus 8x squared plus 3x plus 18, that is the same thing as if I had gone up here to that x plus 3 and come over here to get the last bit right there and write it as 1 degree less, so 3x squared minus x plus 6. That this original function actually factors to this. By knowing that the remainder was 0, we knew that x plus 3 was a factor, and the other part of the factorization is actually the quotient. So those two multiplied together are a factorization of our original problem. Really, really important stuff, and kind of an easier way to factor a higher powered thing. Okay, so let's try one more with our next example. To determine if x plus 1 is a factor, we're just going to start out here in our box. X plus 1, so we'll put in a negative 1. Descending order here, we got a 2 for the x to the fourth, a 1. We don't have an x cubed, I'm sorry, an x squared. We have a negative 10 for x and a negative 11. So drop down the 2, multiply it to the box, and add it up. Multiply it to the box and add it up. Multiply it to the box, add it up, and it looks like we're good. So again, I'm going to kind of show you the unique trait with all of this is the fact that if I took 2x to the fourth plus x cubed minus 10x minus 11 and I wanted to factor it, it's the same thing as going, okay, x plus 1 times 2x, and we're going to drop that degree by 1, so cubed, minus x squared plus x minus 11. And that's what that is in the process of factoring. And then, kind of like before, because the remainder was 0, that we also know that x equals negative 1 is an x-intercept. So another important information if I want to go about eventually graphing.